Okay, so let's review physical and chemical properties. So remember, a physical property is anything you can observe about a substance without changing the substance. This is pretty much all of the things we think of as properties, right? So I think the easy thing to do is just, if you can just look at the color, right? You can smell something. You can freeze, boil, or melt it and see what temperature it does those things at, right? It's still the same substance, right? Remember, ice and water and gas, steam, are all H2O molecules. So it's still water, so it's still physical. Is it magnetic? Does it conduct electricity? Does it dissolve in water? What's the density? All of these things we can figure out without changing the substance, without causing any sort of reaction. So these are our physical properties, okay? Chemical properties. There's not a huge amount of them. It's basically, does it light on fire or does it react with something in some other way, right? That's pretty much it, okay? These are the ones that we can only tell if a chemical has these properties if we change the chemical, right? If we light something on fire, it is no longer the same thing. A piece of wood that's been lit on fire is not wood anymore. It becomes like ash. Same with paper or gasoline. When we light gas on fire, it turns into water and CO2. So we don't have gas anymore. That's why we can't just run on the same tank of gas the whole time. Reactivity. Some things react in different ways. And we can kind of look at those here when we look at our chemical changes, right? If we see something change color, it reacted and became a new thing, right? When bread turns brown after baking, that's a new chemical. It's called acrylamide. If something changes its smell, that would be evidence of a chemical change. Right? Ash, right? It was wood, now it's ash. That's a new chemical. If it starts to bubble, right? When you add baking soda vinegar, it starts bubbling. That's CO2 gas, right? You don't have baking soda and vinegar anymore. In fact, if you add vinegar into a beaker, you can smell it. If you add a bunch of baking soda, you'll notice that the vinegar smell goes away because there is no more vinegar. It becomes carbon dioxide gas and water. If it creates heat or light, so like when it's a fire or an explosion or something like that, that's a chemical change. So all of these things tell us a reaction happened, and if a reaction happened, we would call that a chemical property or a chemical change. So again, chemical change, lighting things on fire, things like rotting, right? It has a new nasty smell, it has a new nasty color. Rusting, right? Iron, it starts off as a nice shiny silvery metal, and it becomes kind of a red-orange, rusty kind of color, right? Digestion, you start off with food, and then later it's not food anymore, right? Kind of takes on a nasty smell, if you know what I mean. Compare that to our physical changes, right? If you chop a tomato, it's still pieces of tomato. You boil water, it's still water. Melted chocolate is still chocolate. You shred some paper, each of those strips is still paper, okay? So physical and chemical changes aren't too bad. Just make sure you understand that all of these are examples of a chemical change, right? But, like for example, changing color is an example of a chemical change, but color itself is a physical property still. Make sure you don't get confused by that. You can look at something's color and see what it is. Changing its color, though, changes what it is. That's the difference there, okay? So if you can see it or smell it, it's a physical property. If it changes what it looks like, if it changes its color or it changes its smell, then you have a chemical change and you know that that thing reacts, okay? That's pretty much it for chemical and physical properties. Pretty simple one.